Cool. So we're here to talk about transformational operations, or at least that's what I keep on getting mixed up in my head whenever I'm talking about it. And funnily enough, that makes me think of things like this. Transformational operations, plastic surgery, gone wrong, amazing stories. But actually, what we're talking about is operational transformations. And as you can see, the imagery is just as compelling. So I guess the first question is, who am I and what am I doing here? My name is Jason Green. I'm a principal developer at Thread Styling. Now, Thread Styling, we are, and this is the marketing line, pioneering 21st century personal shopping through chat and social media. What that more or less translates into is we're selling very high value items to rich people over Instagram. Now, the current world of social media and chat is not really anywhere near as set up for e-commerce as the plain old internet. So that gives us developers a lot of interesting problems to solve. And one of those problems is what led us to operational transformations. Which brings me to the what am I doing here? And the reason I made this talk is because at the beginning, when I first started looking into it, I had no idea what I was doing. I've been working at Threads for the past year, and we've been working on building a CMS. We knew we wanted the CMS to allow for concurrent editing, so multiple users working on what is essentially the same document at the same time. And I did a lot of research on the subject. And I'm not afraid to say that I felt at the beginning completely out of my depth. But now that I do get it, what I'd like to do is share that understanding, and that's kind of mainly what the talk is about. So this isn't about getting you to use a certain piece of code, but more so giving you a vocabulary of concepts that you can use to build your own sorts of concurrent editing systems. So that there, concurrent editing with JSON patch and operational transformation, is the solution that we arrived at. But let's take a look at that piece by piece and how we got to the solution. So what is concurrent editing? It's multiple users working on the same document at the same time. It can be, well, it requires real-time or at least semi-real-time updates of other users' changes. So it could be a text document, it could be a JSON document, it could be a list of complex objects. And it's become essentially an expectation in online CMSs. So most document editors that you use online, all the big ones like Google Docs, Draw.io, flowcharts and things like that, they kind of have some kind of concurrent editing as standard. It's just an expectation. So why did we need concurrent editing? Well, we needed to build the CMS. And having built a very complex CMS before at the Mail Online, I've had my fair share of avoiding implementing concurrent editing. We had stakeholders repeatedly telling us that we didn't need concurrent editing, that they didn't want people to be working on the same document at the same time. And it's not very agile to do big design up front. You don't want to write code that you're not going to need. So we avoided it. But then one day the big boss comes over and says he wants to be able to edit the headlines of stories while journalists are editing the story itself, because he likes to micromanage. It's all about, I mean, if you've seen Mail Online headlines, they're like this big, so it takes some effort to get those. So suddenly we think, okay, how do we do this? And we implement a hack, because we've never thought about it from the very beginning. It's not been part of our consideration. So you have to kind of build in a hack. If you don't have concurrent editing, you have to have some kind of locking. And locking is not as simple as it seems either. Locking documents, and then people want to be able to override a lock on a document. And then what happens to, you have permission levels, and what happens to the person who got booted from the article. It becomes a whole mess. So you'd think this is a solved problem, right? I mean, there's Google, there's big players, they all like to open source. Surely this is just a piece of a library we can pick up and just run with it. Well, for specific use cases, I found a lot of good solutions. like rich text editing, if I'm remembering correctly, I think it was ProseMirror, does amazing concurrent editing. That's great. But not so much for arbitrary data structures. And then there are some solutions that require a big buy-in and also kind of handing over the ownership of your data in a way, and especially the way your data is stored. It becomes opaque to you rather than understanding what's going on and having it be transparent. So it sounds like we're being really picky. So what did we want? Ultimately, we wanted to do the minimal amount of work that we could to give ourselves flexibility while moving forward. We wanted to keep it as simple as possible in an agile sense. We wanted to own our data and control it. We wanted to keep it flexible, so some fairly simple underlying way of storing data, but everything else on top just acts like a normal app. We wanted to understand how it's working. We wanted to keep data eventually consistent across multiple users. And as I said before, we need to support arbitrary JSON data structures. So what were the options? Well, I had a look into a few different ways of managing concurrent editing or managing diffs between different users. Conflict-free replicated data types are very interesting. What they essentially do is they create change. They have algorithms for applying changes to things, and they do it in such a way that you can never have conflict. And I do not want to explain it because I barely understood it and now I've forgotten it. But it's interesting to look into, but it's more for giant distributed systems like Redis and React. It's for when you've got many, many nodes and there is no one true owner. The idea is all the changes become commutative, so they can be applied in any order. And just the fact that all changes were commutative, that alone made me want to find out how, what do they mean by that. But I'll let you guys look that up in your own time. So next was differential synchronization, which is what Git and SVN does. And now this is very good at giving a lot of context for changes. It's good, but it requires manual intervention. And ultimately, we didn't want that, and we don't need that level of granularity in the documents we're editing. So finally, operational transformations, which is used for Google Docs. And so let's look into that one in more detail. So I think this is the only wall of text in the presentation, but I'm just going to quickly read it out. So operational transformation is an algorithm or technique for the transformation of operations such that they can be applied to documents whose states have diverged, bringing them both up to the same state. So every change or an insertion or a deletion is represented as an operation, like a single thing. And the operation can be applied to the current state to bring it up to the new state. And then you also have to have a way to transform those operations if they need to be changed because of previous changes that have not been accounted for. So I've done a little animation that hopefully will simplify that a bit. So let's say the server has ABC in its state. Client 1 comes along and inserts an X at position 0. Now client 2, without knowing about client 1's change, wants to insert a Y at position 2. But more correctly, it doesn't care about what position it is. What we care about is context and preserving the intent of the change. The intent is to put a Y between B and C. That's kind of the more important part of this. So when that goes into the server will transform that change. It has to know the changes that client 2 didn't know about. So it knows that it didn't know about this first insert, so it just bumps the index up to 3, and then it can send that back to client 1, or send that over to client 1, so client 1 gets up to date, and send the change back along with the missing change to client 2. And client 2 may have optimistically applied that first change, but it can roll it back and now reapply those two insert operations. So why was OT the right solution for us? Well, it can resolve all types of conflicts in an acceptable way without human intervention. And that's acceptable to us, not necessarily to every use case. It's good at preserving the intent of changes. Once again, not perfect. Human intent is going to be a bit mystic for what is essentially an algorithm. But you can tell it can figure out the array positions and things like that. It works well with the central source of data, which was fine for us. And it can handle offline working okay. I put okay because, once again, if you're working offline for a while without getting updates, you may be working on a whole piece of data that someone's essentially gone and deleted. So the longer you stay offline, the less useful it's going to be. It works well with a series of changes as the source of truth. So that's another thing to give ourselves flexibility in the future. If we ever wanted to roll back a document to a point in time, or we wanted to very simply implement undo and redo, we wanted to represent and persist our documents as a series of changes rather than here's your document, we update it, there's the document again. Okay, so that worked for us as well. And it's relatively easy to reason about. Finally, on to JSON patch. Where does that come in? Well, JSON patch is a format for describing changes in JSON documents. So it kind of seems perfect. It's essentially the operations in operational transformations. And funnily enough, that's actually what they call them. So you can see that OP, add and OP copy, move, replace, that stands for operation. So JSON patch is standardized. It's a standardized way of representing changes. It's serializable, modifiable, very easily modifiable. It's just a JSON, which essentially becomes a JavaScript object. It's familiar to those who use it. Readable and easily reversible. As long as you record the old value whenever you're operating on a value, you can kind of run through the whole stack back and forth and bring your document in line with any point in time. And yeah, so I actually find it makes it easier to reason about operational transformations when you're representing them as JSON patches. So how it works between server and client. So knowledge sharing and feedback is very important to us at Thread Styling. So a lot of big projects, when we kick them off, we'll have group discussions. Someone may be working on it, but they'll share their findings and their approach with the rest of the team. And these diagrams are essentially what I showed to the team very early on, about a year ago now. So in this case, I do realize I wrote initial document, but actually what that initial document is a list of changes. And the server may be storing snapshots of the document at different points in time in order to speed up in order to speed it up, but you wouldn't even need to. You could just have the list of operations, and at any point you can pull together the entire document by just applying them all to each other. So that document gets sent over to the client. In the meantime, client is minding its own business, and some other changes are being sent over by someone else who's editing the document. As you can see, their changes are being stacked up there. Notice we have a change ID, so when it sends over the initial state from the server, it sends over the last known change ID as well, which the client knows about now. So the client now comes along and says, okay, I need to add a slide at slide 2, and it's going to be an object with the title of my slide is the best. It also sends along the last known change ID with it. Also, at this point, the client may have optimistically applied that change to say, okay, look, this should be fine. The server gets hold of that change. It finds every change that happened since the last known change ID, and then it transforms that new change against all previous unknown changes. That's where the library comes in that we've built, that we wrote, and it's really quite simple, but that's kind of the main interesting part of the logic. So it transforms, it has a bunch of rules for what it does with indices and with different values. And then it changed, so you can see it changed it to slide 3 rather than slide 2. And it sends it all back over to the client, who can then roll back the erroneous change and then reapply all those new changes it's just received. This means that you can, not only do you have concurrent editing, but handling something like undo and redo is a real breeze. And also having built a CMS without considering undo and redo before, I can say that that is really painful. So it's a nice freebie there. Another cool thing is that if you want to create snapshots of your document over time, if you want to give users the ability to say, oh, I'm going to save this, but keep on working, it's as simple as a pointer to the change ID. That's your document at that point in time. So what this all has led to is a library called threads JSON patch OT. So you can you can go and try that out, of course. There's an example. There's also an example client-server project, which we'll have a look at in a second. But basically, I'll just quickly show you what the code looks like inside that, the example. So we have a, what is this, book? Okay. So we have React components that look something like this. They have all of their different, so this is a book in a list of books. You can move the book up, you can move it down, you can delete, you can change the title, the author, the color. For some reason, my book has color. And you can say whether or not it's in stock. I've created a change handler that basically generates JSON patches and sends them off to the server. And so you can pretty much see the correlation there between move and delete and what sort of operations they're creating. The main parts of the server are very simple. There's the main get request. The get simply gets all of the operations that are for this particular document. It applies them against an empty object. And so all of those changes, and those are all JSON patch operations, will be applied to this empty document, and you'll come out with your actual state of the document. So that's your result. It then returns the resulting new document, and the last known operation ID to the client. The client will receive that and can display it in the React client. And the other route is the post route, which is where we send our changes to. So this is also fairly simple. It's simply getting the last known operation ID, which has been sent along with the request. It pulls out the patch, which is a list of operations. It gets all of the operations that it knows about, the server, and slices them at the last known operation ID. So this is obviously all a very simple implementation where we're just keeping a list of operations in memory or whatever. But it then does a JSON patch OT. It does the JSON patch OT function where you pass in the unknown changes, the brand new patch. There's one option there, which is accepted wins on equal path. So this is basically if you do a replace on path A, which one wins? And one of the previous unknown changes has done a replace there as well. Is it the newest thing? Or given that the new thing didn't know about that old change, is it the old thing? So simple as that. That gets you back your transform patch. That gets pushed onto the operations. So that line is essentially committing this and saying this is a brand new known operations. We're persisting these now. And then it returns back to the client the changes to apply, which is made up of unknown changes and transform patch, and the brand new last known operation ID. So with that amount of code, we essentially get a concurrent editing system. So I'm going to see if I can navigate my way around now, doing everything backwards. But I've just started my server. This is the JSON patch example that you should have a link to. Well, sorry, that you'll be able to check out in your own time.
Could you make the font a bit bigger?
Yes, I'm actually going to open up some. The main thing, like when it comes to looking at the code, it'd be better just to check it out online. So I'm just going to open up these. This is essentially the app. So, oh god, this is awkward. And can I go paste? Yeah. So. basically everything's happening on the server. The client, I can do it in this case because I don't have to optimistically apply anything. I can wait till I get my response and then apply it. So it's really very simple. So if, for example, here we change the color to something else, and on this other client we decide we're going to change this, it updates because it got the unknown changes. Now in that case there was no, what do you call it, there was no conflict. So if we add a few more, okay, so now, so now if we, let me think, so if I go and change the title of this, oops, but I delete one up here, essentially it's going to be sending to the wrong path. Sorry, I've got to do it over here. So I'm going to delete this one. Yes, and because that didn't know about the one it was missing. Okay, anyway. And now if I hit OK, you can see that it did change the correct one. Now I think about it's probably difficult for you to tell because they all say enter title. But you're going to have to trust me on this. So yeah, that's just, you can play around with it yourself. In terms of, I've got one issue on the repo, which is that we could do more to handle move operations. So if I'm editing an object in a list and someone moves that exact object somewhere else, there's no reason we can't deal with that. At the moment, it just ignores your changes because it doesn't know how to deal with it. But there's no reason we couldn't actually apply those changes to the new position of the object you're moving. It hasn't been needed in the project we're working on because we've essentially split up our, we have an array that shows the order of the objects, and then we have a hash that has all of the objects. Actually, someone did tell, oh no, I don't have internet, so I can't do it. Someone did tell me that it's easier to talk this through actually if I show you a picture of our app because it's kind of all a bit abstract, I appreciate. Let's see how I go. Ooh, there we go. Guest. And I said I can do a fake name. Oh. And fake email. It's not going to get away with that, am I? That's too fake. Oh yeah, okay. J at is going to be looking for some, actually I don't know if it worked. Anyway. Story maker? No, it doesn't work. Never mind. Basically, it's a bit like Instagram. You have, but imagine instead of an Instagram story where you have one story, we wanted to give our users the ability to create multiple, like long-running stories with multiple slides. So multiple slides, overlay elements, text that you can rotate and stuff like this, but we wanted to also allow them to work on it concurrently. So going back to my presentation. Yep, that's me. We are slowly but surely trying to build up our tech profile. Threads Eng is our Twitter. We've been, we recently did an open source meetup with just a major player in the open source world. He's at Gaius. He has been talking about his open source journey and giving them just an amazing amount of hints and tips on how to build an open source community. So if you go to our meetup page through meetup.com or threads.biz/meetup, we have our own URL shortener, then you can go there and I've put the link to the video. It's filmed on an iPhone because we're still not sorted, we haven't sorted out this level of professionalism yet, but it's full of content, full of really good, useful tips. Yeah, so that's me. Thanks.